Hi everybody. So today let's talk about the compensation point. First, let's read the question. Diagram 4.4 shows the changes in volume of CO2 absorbed during photosynthesis or released during cellular respiration by the plant in different light intensity. So in this question, actually it talks about the interaction of photosynthesis and respiration in plants. So what is the relationship between photosynthesis and respiration in plants? Photosynthesis produces the glucose, which is to be used by the plant to carry out respiration. And respiration, on the other hand, releases the CO2 that is to be absorbed by the plant for photosynthesis. Alright, now let's examine this graph. So as you can see, the x-axis refers to the light intensity, and the y-axis here refers to the absorption or the release of CO2. Bear in mind that the CO2 is released because of the activity of respiration, and then the CO2 is absorbed because of the activity of photosynthesis. However, photosynthesis and respiration occurs together when there is light in plants. Now, let's see what can we do on this diagram. So the light intensity can be divided into three types here. Number one, the light intensity is very low. Number two, it's medium, and number three is high. Alright, so what happens when the light intensity is low? So you can say that when there is no light, or when the light intensity is low, the rate of respiration would be greater than the rate of photosynthesis. As a result, there is a net loss of glucose, because glucose produced by the photosynthesis will be used up by the respiration. As a result, the CO2 release is greater than the CO2 absorbed. Now, what happens when the light intensity is sufficient so that the rate of photosynthesis is the same as the rate of respiration? So at this point, which is at U, there is no net production of glucose, because the glucose produced during photosynthesis will be used up to produce energy during respiration. So the CO2 release is equal to the CO2 absorbed, as shown by this graph here. Yeah, at U, the CO2 release and the CO2 absorbed is actually zero. There is no net absorption or release of CO2. Alright, now let's look at what happens if we adjust the light intensity to the greater intensity. Now at this time, the rate of respiration will be lesser than the rate of photosynthesis. As such, there is a net production of glucose, since photosynthesis, the rate of photosynthesis is greater than the rate of respiration. This time, more CO2 is absorbed by the plants to carry out photosynthesis, and then the CO2 released by the plant during respiration. Okay, so alternatively, we can understand it this way. Now let's treat the glucose like money. Respiration uses up money, the glucose, and the photosynthesis produces money, the glucose. So if the respiration rate is greater than the rate of photosynthesis at low light intensity, then what happens to your the glucose in the plant? So there is a net loss of glucose, so your savings go down. When the light intensity is sufficient so that the rate of photosynthesis is the same as the rate of respiration, then there is no net production of glucose. So what happens to your savings? So it remains the same. If you increase further the light intensity, this time the rate of photosynthesis will be greater than the rate of respiration. It is when the plants will have a net production of glucose. Then in your bank account, your savings go up. Alright, so hope you understand this graph. What is meant by R, U, and P. To recap, U is the compensation point. This is the point when the light intensity is sufficient so that the rate of photosynthesis is the same as the rate of respiration. Below compensation point, which is this part, the rate of photosynthesis is smaller than the rate of respiration, so there is a net loss of glucose. Beyond it, beyond this compensation point, the rate of photosynthesis will be greater than the rate of respiration. This is when the plant will have a net production of glucose. So if you were farmer, how would you adjust the light intensity to maximize your return, to increase the growth of your crops? You need to make sure that the light intensity must be beyond the compensation point. All right. So if you allow the light intensity to be at this point, so what will happen to your crop? Basically, the plant, the growth of the plant will be stunted because there is no net production of glucose. Okay, so see you then. Thank you.